All right, so to recap all that we did on the last page, and we have a memory kind of aid to help you with this because I know that's a lot of information. But basically, in quadrant one, all trig functions, when you take any of them, of all six, um, sine, cosine, cosecant, etc., of theta, the answer will always be positive. In quadrant two, we said that it was sine and cosecant. In quadrant three, it was tangent and cotangent. And then in quadrant four, it was cosine and secant. So to help you remember all this, if you take a look at this little picture here, it's your coordinate plane with a circle, and we have our quadrants. So what's kind of nice about this is if you have quadrant 1, 2, 3, and 4, there's this that's a memory device that says all students take calculus. So the A is going to stand for all, and that means all of our trig functions are positive in quadrant 1. S is sine, and what that means, and I'm going to write this down here, and you might want to do this to understand, is that the sine function and its reciprocal cosecant are the only trig functions that are positive in quadrant 2. So I know that's sloppy. It's hard to write with my stylus. But what that means then is if we go to T, that stands for tangent. So the only trig functions that are going to end up being positive in quadrant 3 are tangent and cotangent. And then in quadrant 4, C stands for cosine. Then the only trig functions that are going to be positive in quadrant 4 are cosine and its reciprocal, which is secant. So if you can kind of remember all students take classes, it's going to help you with our last page. Okay? So really quickly before we talked a little bit about those reference angles that are between 0 and 90. And just to kind of remind you, if you have a 45-45 right triangle, we said earlier that if this is 1, the other leg is 1, and you would multiply the legs by radical 2. So you're going to need to kind of bring this back. And then a 30-60-90, if our short leg, which is across from 30, was 1, you're going to multiply that by radical 3 to get the long leg, and you take the short leg and you double it to get the hypotenuse. So that's just review, but that's going to help us as we do these examples below. Okay? All right, so here is the deal. We're going to do the next examples together. You might want to try some on your own, pause it if you want to speed up the video once you get it and check it. But the issue here is that this is all no calculator. Now, of course, I'm not going to know you're not using your calculator until you have to do this on a quiz without one. But the key thing here is you can always check your answer, but we're going to follow these steps. So notice it says determine the exact value for each of the trig functions. So number 1 says rotate to the quadrant the angle is in and draw the reference triangle. So if I take a look at where sine of 135 would be, that's going to land in quadrant 2. I'm going to go ahead and draw my right triangle. So here's the deal. I'm going to go ahead and remind myself that we are landing in quadrant 2. And that's a big deal. Now, if we think about 135-degree angle, okay? Think about that reference angle that we did earlier in these notes. This is where it comes in handy. So our reference angle to get all the way from 135 to 180, which is the x-axis, would be 45 degrees. So the reason we're going to use the reference angle, and I hope you see its purpose now, is that we don't know the sine of 135 off the top of our head, but we can do the sine of 45 off the top of our head because it's a special right triangle. So we know if this is a 45, 45, 90, this leg is 1, this is 1, and this would be radical 2. So if what I'm trying to do is I'm trying to say, ooh, the sine of 45 and the sine of 135 are going to be similar. And when I say similar, here's what I mean. If you were to take the sine of 45 degrees, that would be opposite over adjacent. Now, the 45-degree angle, if you think about it, think about quadrant 1. We didn't have to worry about anything in quadrant 1 because 45 degrees would land in quadrant 1 and everything would be positive. But instead of you having to worry about, oh, this is negative and that's positive, if you remember in quadrant 2, that's where all students, so if I think about our little reference here, all students take calculus. We're in quadrant 2. That means sine and cosecant are positive. So if I know that the sine of 45 degrees, if I rationalize it, it would be radical 2 over 2. Well, that's going to be the same thing as the sine of 135 degrees because it's its reference angle. And it's actually going to stay positive because we're in quadrant 2 and all sine functions are in quadrant 2. So the difference is the sine of 45 would be in quadrant 1, but we use that reference angle to do something familiar because we don't really know what 135 is. So you're done. Your answer is radical 2 over 2, and if you would check it on your calculator, that's exactly what you would get. Okay? All right, let's go on and see if you're catching on. So let's look at the cosine of 210. So the cosine of 210, if we think about drawing that angle, that would land down here in quadrant 3. So we're going to draw our reference triangle, and we have theta, okay? Now, our reference angle, or I should say theta prime sitting underneath here, is what angle is going to get us back to the x-axis. Now, I know this is 210, but we have to go back to the x-axis. So that's going to be 210 minus 180. So our reference angle underneath here is going to be 30 degrees. So I'm going to change that into a 30. So in a 30-degree triangle, we know that that's opposite from the short leg, so that would be 1. The long leg would be radical 3, and the hypotenuse would be 2, just like in our special right triangle above. So the cosine 30 degrees, right? And we have a 30-degree angle. Now I know we're in quadrant 3, but think to yourself, well, I don't have to worry about any sines or anything. The cosine of 30 in quadrant 1 would be adjacent over hypotenuse. Well, the cosine of a 30 and the cosine of 210, I don't want to say are exactly the same. I want to say that they're similar in that, yes, we're going to still use radical 3 over 2, but we're in quadrant 3. And if I go back up here to my little all students take calculus, the only trig functions that are positive in quadrant 3 are tangent and cotangent. So this is going to be negative. So our answer is the cosine of 210 degrees is negative radical 3 over 2. All this really does, this all students take calculus, is it saves you time from having to remember that you went to the left, and so that would be negative radical 3, and then you went down on your reference triangle, and that would be negative 1, and then your radius is always positive. So it kind of just saves you time when you're trying to do it a little bit faster. Okay? All right, let's do this last one together, and then I'm going to have you probably pause the video and try the last 3 on your own. So we have the tangent of 315, so we're going to go all the way around. We're going to land in quadrant 4, so there's our 315-degree angle. So our prime theta, our reference angle, after I draw my reference triangle, would be 45 degrees. So we have another 45, 45, 90. Shocker, we're going to, because that's what we know. So the both legs would be 1. And once again, I'm not worried about my signs right now because my all students take calculus is going to take care of that. And then my hypotenuse would be radical 2. Well, the tangent of 45 degrees would be just 1 over 1, which is 1. Well, the tangent of 315 is also going to be 1, but you have to remember your signs. So we're in quadrant 4. Well, if we look at all students take calculus, positive down there is going to be cosine and secant. Tangent doesn't fall into that category. So the tangent of 315 degrees is -1. Check that on your calculator. You're going to get the same thing. Now, I'm going to pause the video as you pause, and you should check your answers for the last 3 with mine. So I got these last 3, 9, 10, and 11 set up, so hopefully you can kind of check as I go. So in number 9, the cosecant of 60 would be the same as 1 over the sine of 60. Well, what's cool about this one is that we literally already have the angle. We are in quadrant 1. We have 60 degrees. So if I drop this perpendicular, okay, we have our short leg would be here, radical 3 and 2. So if I take a look at this, we would have 1 over, well, the sine of 60 would be equal to radical 3 over 2. So 1 divided by radical 3 over 2 equals 2 over radical 3. And when I rationalize my denominator, I get 2 radical 3 over 3. Okay? So that means 1 over the sine is the same thing as cosecant. So our answer is positive 2 radical 3 over 3. How do I know it's positive? Because we landed in quadrant 1 and all functions are positive in quadrant 1. And number 10, so number 10, the cosecant, of 120 is the same as 1 over the cosine of 120. Well, we don't know the cosine of 120 off the top of my head, so I'm going to use the reference angle. So that reference angle is going to be 60 degrees. And so if I have my right triangle, across from it would be the long leg, so that's radical 3. Here would be the short leg, and then our hypotenuse would be 2. So 1 over cosine of 120 would be similar, not same, and I say that only because of the sine of 60 degrees. So that would be 1 over the cosine of 60 would be adjacent over hypotenuse, and 1 divided by 1/2 is 2. So therefore, the secant of 120 degrees is equal to 2. But is it 2 or -2? Well, since we're landing in quadrant 2, and all students, the only thing positive there is sine and cosecant. And secant does not belong in that category, so our answer is -2. And finally, our last example, the cotangent of 330 is equal to 1 over the tangent of 330. So I have that angle set up, but our reference angle, if I slide it in here, would be 30. Okay, so we now have another 30, 60, 90. So across from it would be 1, adjacent would be radical 3 and 2. So since 1 over the tangent of 330 is similar to 1 over the tangent of 30, and I can say same loosely, that would be 1 over, the tangent would be opposite over adjacent. Well, that would just be 1 divided by 1 divided by radical 3 is radical 3. So the cotangent of 330 degrees would be radical 3. However, since we're landing in quadrant 4 and all students take calculus, tangent is not positive there, so your final answer would be negative. And I did check all these on my calculator just to make sure I was doing this right, as you should too. But I'm hoping this helps. And that wraps up our notes for 2.4 part 2. Now you'll be